Welcome back to Advent of Code 2016. We're on to problem 12. Leonardo's monorail. Monorail, monorail, monorail. As per the song. Right. Let me just... Alright, let's read this. Oh, there's a monorail involved. This sounds fun. Oh. Looks like it's assembly. There's always an assembly problem. Alright, doesn't look that complicated though. Alright. You finally reach the top floor of this building. A garden with a slanted glass ceiling. Looks like there are no more stars to be had. While sitting on a nearby bench amidst some tiger lilies, you managed to decrypt some of the files you extracted from the servers downstairs. According to these documents, Easter Bunny HQ isn't just this building, it's a collection of buildings in a nearby area. They're all connected by a local monorail. And there's another building not far from here. Unfortunately, being night, the monorail is currently not operating. Just reminds me of the monorail in Simpsons, which was solar powered, actually. You remotely connect to the monorail control systems and discover that the boot sequence expects a password. The password checking logic, your puzzle input, is easy to extract, but the code it uses is strange. It's assembly code designed for the new computer you just assembled. What's this? Oh, that's what the microchips are for, okay. You'll have to execute the code and get the password. The SemBunny code you extracted operates on 4 registers, A, B, C, and D, that start at 0 and can hold any integer. However, it seems to make use of only a few instructions. Copy XY copies X into register Y. Okay. Inc X, Dec X, jump. XY. Jumps to an instruction Y away, but only if X is not 0. Jump not 0, X. Jump Y. Okay, got it. Okay. This looks super easy. What could go wrong? Alright, well, let's copy that in. Oops. Alright. Alright. So we just execute the instructions. I don't think there's any algorithm needed here. So, how do I make the font bigger? Okay. Instructions equals z.strip for z in read lines. Alright, so A, B, C, D equals 0, 0, 0, 0. So for each instruction, okay, so the program counter PC equals 0. That's the first instruction. Alright. So when does this terminate? When we run out of when you move past the last instruction. Okay. While true. Wait, no. While PC is less than length instructions. Equals PC dot split. So that's the tokens. Okay, we've got to do it like this. We've got to say register equals a or just say car 0 for car in ABCD. Okay. Now we just check if okay, what's the possibilities? Let's say ink and deck first. Ink do register let's just simplify this. All right, register inst 1, so the next parameter will be the letter, plus equal 1 equals okay, similarly elif deck minus equal 1 elif inst 0 is copy. So either it's a letter if inst 1 dot is digit, so if it's a number, then register inst 2 equals or just say equals int inst 1 if inst 1 dot is digit, else we can just copy the register value, so else register alright, just take this out. Okay, that's a one-liner. Else, the only other possibility is that we have JNZ. Okay. Jump if not equal to 0. Okay, so else. If register inst 1 is not equal to 0, program counter plus equal int inst 2. Now, we always increment the program counter. So here, let's just subtract 1 just to account for that, because we don't actually want to do it in this case. In every other case, we do. Okay. Now, what is the actual result we want? What is the value left in register A? Okay. Print register A. Okay. Key error 1. If register inst 1 jump not 0. Oh. It can actually be an integer. Interesting. Alright, fine. To compare equals that. So we can just take the integer. So you can create jumps that just unequivocally activate. Okay. 318077 seems quite big because we're only incrementing and okay, fine. I didn't think it would be that big, so how does the loop actually keep going? Let's have a look. Let me look at this again. For that few instructions. So it's copying stuff around, copying 26 in jump. Something interesting is going on there. I don't really understand. But it's, I mean, you're only dealing with jump, not zeros, so -2, -6. Okay. Just trust in the program. Alright. Straightforward enough. Part 2. As you head down the fire escape to the monorail, you notice it didn't start. Register C needs to be initialized to the position of the ignition key. If you instead initialize register C to be 1, what value is now left in register A? I'm worried now. I mean, just do the same thing, right? With 1, but is there something gonna go wrong? Is it gonna take too long? I can't think what kind of algorithm you would use in that case. Alright, let's just do it. Alright, let's say... Let's define a method. Define execute. Alright, so we can do... Take that out. And now we do this again. So that's part 1. This is part 2. But register... So what was it? C. It's 1. Alright. See, does it actually run? It's going to take a long time, isn't it? I can't think what algorithm you would use other than looking at the input manually. Okay, we've got something. It's in the millions, but not too bad. That's got to be correct, surely. Like, how could it not be correct at this point? Okay. Alright then, I did that pretty quickly, but I think ChatGPT will probably do it even quicker, so ChatGPT will still get the win. Even though I would say it would roughly be a tie. But ChatGPT is faster. Well, let's see. Let's see what happens. So, and overall that took me what? 15 minutes? Okay, so just copy what I said before. So I mean, if he solves both parts in 10 minutes, then he's beaten us. So all right, okay. Right. So all right, so oh my god. Okay. Let's test this out. It's definitely faster. He's beaten us again. Alright. Part 2 though. It's literally changed C to be 1. He's not going to struggle with this. Alright. Now adjust the program. Now produce a Python program with the following modification. Register C to 1 instead of 0. Yeah, I mean, he gets it. Of course he gets it. It's literally just changing a 0 to a 1. Alright. Probably take the same length of time. I mean, there's no algorithm for solving this. You've got to do it step by step because anything could happen in those instructions. Yep, that's correct. So you can't make any assumptions. So I don't think there's any algorithm that can solve this. You could simplify loops if you recognize what's happening, but there's so many different things that could be happening, you can't account for all of them. So like if you realize something something was going to take a million steps to complete, you could just skip those a million if you knew what would happen, where you would jump to after that happened. It's very difficult though to do something generic that can solve anything like that, because you don't know what matters and what doesn't in each of those registers. So yeah, just have to solve it step by step. All right. So yep, ChatGPT wins again. Let's make a scoreboard. Hang on, how do I do this? Coding text. Hang on. Coding. All right. What do we say? Hex tree. So what? That was 12 problems. We've lost. Well, okay. We won twice. ChatGPT won 10 of them. Can I put a background on that? Sorry, I'm just making it look pretty. There we go. All right, on to 13. Oh look, we've got a monorail moving. Does that only happen after you solve 12? Oh, that's cool. I think so, yeah. 13. A maze of twisty little cubicles. Nice short description, okay. Honestly, the short descriptions are actually easier. Sometimes that's not the case in coding competitions. The shorter the description, it's just makes you, it just puts me on edge because I know it's going to be a really tough problem with a short description. But in this case, short descriptions are usually the easier ones, I think. Okay. So, you arrive at the first floor of this new building to discover a much less welcoming environment than the shiny atrium of the last one. Instead, you are in a maze of twisty little cubicles, all alike. Every location in this area is addressed by a pair of non-negative integers xy. Each such coordinate is either a wall or an open space. You can't move diagonally. The cube maze starts at 0, 0 and seems to extend infinitely towards positive x and y. Negative values are invalid as they represent a location outside the building. You are in a small waiting area at 1, 1. So I'm guessing the 0 row and column are walls. While it seems chaotic, a nearby morale-boosting poster explains. The layout is actually quite logical. You can determine whether a given xy coordinate will be a wall or an open space using a simple system. Find x squared plus 3x plus 2xy plus y squared. Add the office designer's favorite number, your puzzle input. So we don't really need to use an input file here. It's 1358, okay. Find the binary representation of that sum. Count the number of bits that are 1. So it's each one. Okay, fine. Yeah, okay. Number of bits of 1, it's even. Okay, fine. I don't think there's really a quick way of doing that. You just gotta do the actual sum. Yeah. Okay. Yeah, fine. So this is what it might look like. I suppose you want to reach 7-4. The shortest route you could take is marked as 0. Okay. As O. Oh, it's just walking through a maze, but you're calculating the walls as you go, as you find them. You don't need to calculate every... Okay, fine. 31, 39. It's just breadth first search, and this is not a complex sum. You just need to do it. So 31, 39 is not even very far, but do we expect it to be roughly random? Roughly 50-50 chance of each being a wall, or is there going to be a pattern here? I mean, if x's and y's are powers of 2, no, that wouldn't necessarily mean anything. Because, okay, interesting. Alright, I don't see anything complicated here, just normal BFS. Alright, 1 second, I'll be right back. Okay, so no input file needed here. So it's 1358. Okay. Okay, so seed, just call it seed. All right, define. Okay, so we probably want to import. Well, it's yeah, we want the queue. Okay, so from Could make it A star. Don't bother. Just do BFS from Q import Q. Yeah, ChatGPT is definitely going to beat me here. It's a very standard BFS. He knows how to code it. Right. There's barely any setup needed here. We just go straight into BFS from start to goal. Okay. Q equals Q. Okay. They said you start at 1-1. So what? 1-1 is always... Ooh, interesting. 1-1 is always going to be... empty space. Okay, fine. Okay, so Q equals Q. Testing starts. Okay, while not Q dot empty. Current equals Q dot get. Or let's say X, Y equals Q dot get. No, I'll just say current. If current is goal, I guess this is fine. We could do it this way. Maybe faster to... Yeah, it doesn't matter. Okay, so we can do the goal check when we find the neighbors, but we can just do it here. Just it takes a few more expansions before we get there. So current equals goal, return dist of current. So we've already found the dist before. All right. Or so we're going left, right, up, or down. So dx dy in, let's just say -1 0 1 0 0 -1 0 1. So these are the 4 possible directions. New x new y equals current 0 plus dx, current 1 plus dy. So this is the neighbor. If uh, 0 is less or equal to so if it's infinite, so as long as so if new x is less than 0 or new y is less than 0, skip this one. So we're in the board. Now we need to check if it is a wall. Mine is wall x, y. So how does it work again? So we got okay, so z equals, so it's x times x plus 3 times x plus 2 times x times y plus y plus y times y plus seed. So then we want the binary representation. So you just do that, right? Bind. Dot count the number of ones. So it's, if it's even, it's an open space. If it's odd, it's a wall. So if it's odd, it's going to be, so we return that %2. So if it's 1, just as a boolean. Okay, easy enough. We can store these values in a hash table so that we don't revisit them, but it doesn't matter, we don't need to. Okay, so we're not going to revisit them often, are we? At most like 4 times each. Okay. So if is wall, right, just say, damn it, x, y equals current. Right, so we, if it's a wall, we skip that one. So now we are on an open space. So if is wall new x new y. Alright, so now we are on an open space. We need to also check that we haven't visited before. So if new x new y not in dist equals dist current plus 1, and now put it in the queue. Q dot put. Okay, that's it. Yeah, and now we just say print BFS from 1 to, what was it? 3139. Just that easy. None. Damn it. So it's getting stuck. Fine. Print. Let's print the dist table just to see what it looks like. Dist is none? No, dist is... There's no dist. Huh? BFS. So it never reaches the goal. Yeah, well, that's to be expected, I guess. If it's not returning an answer. So put this outside the... Print this. There we go. 110. It's not going anywhere. So... How far does it get? dx, dy... New x is less than 0 or new y is less than 0. Continue. If it's a wall, continue. Let's print some stuff here. This looks like we're always getting walls. Huh? Something's gone wrong here then. It's not doing anything. How far is it getting? It's getting here at least, surely. Huh? Oh my god. I didn't put start in the queue. Q dot put start. Oh dear. $96. That was dumb. Easy enough. Right, how many locations, distinct XY coordinates, including your starting location, can you reach in at most 50 steps? Okay. All right. Just run it with a cap and no goal. 50 steps. So yeah, even brute forcing wouldn't take too long. So yeah, that should be fine. So let's define a second BFS. It's 2. Alright, so this one has no goal. Again, we put that in the start. We've got the dist table as before. Get rid of this. Keep the neighbors. Alright, so if if dist current is 50, continue. So we don't look for any neighbors because they would be at distance 51. And then everything else just the same. Don't need to print that. So we say reachable. We're including the initial, yeah, starting location. Okay, so now we just say print. So it should terminate that while loop upon emptying the queue. Okay, so print length of dist. That's the number of visited states. Okay. Or just return. Print BFS2 1. 141? That ran pretty quickly. Correct. Alright, I mean, ChatGPT is going to beat me. This is very basic BFS. This was actually one of the easiest problems, if you know BFS, because it's easier than having to, you know, get a graph from the input telling you which neighbors are valid or not. Because here you've got an arithmetic equation, which is independent of any data or anything. So on the spot, when you're visiting a node, you can say, okay, this position is so-and-so. Use this algebraic expression to work out whether it's a wall or not. That's easier than having to read from an input file and you know, store all the edges in a edge data structure. So this was easier than standard BFS problems. It's a very easy Boolean check. If you know Python expressions for calculating binary representations of numbers, which is not hard. All right, come on, ChatGPT. Let's get this over and done with. There's no inputs. The input is actually written here. Okay, so you arrive, blah, 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 blah. Puzzle. Fewest. Okay, we'll add that line as it stood the first time we saw it. So your puzzle input is that. So it looks like that. Don't say still. There. Bind num.count 1%. Yeah, exactly what I did. Get neighbors. I don't like his get neighbors function. I think mine was actually better in that case. No having to do all those ifs. Just do a for loop for each pause and continues. I prefer my way, to be honest. And my way is extendable to, like, easier to extend to, like, 8 directions and so on. Alright, anyway. BFS, standard BFS, visited while queue. Is using take queue? Okay, fine. Pop left, blah blah blah, get neighbors. Yeah. Yep. Straightforward. I'm pretty sure this will work. $96, yeah. Alright. Program outputs... And I'm looking at what he said here. The program outputs the minimum number of steps, which is 90 in this case. What do you mean 90 in this case? It's not 90, it's 96. Did he try to calculate it? Interesting. Because he tried... How would he? Would he actually run the script or just estimate? Yeah, it's not 90, ChatGPT. I'll tell him. Actually, it was 96. Oh, 90. Just let him know. Corrected code. Well, no. The code was fine. All right. Okay, fine. Stop. Okay, let him do it. Does he actually change the code? I doubt it. All right. Can you adjust the program for the following change? So he's got a max steps instead of a goal. Locations within. He's putting them all in a list. Fine, can do that. Seems pointless if you've got a visited. Like, visited has the same things that this locations within 50 steps does. So you got a duplicate. Alright. Distinct locations visited. Distinct. But they're going to be the same, aren't they? Because max steps, you're not allowed to go beyond 50. Okay, we'll see what happens. $143, $141. Why? I guess because it doesn't actually exit on probably visits 51. Yeah, if steps greater than max steps, you still visit them. Okay, fine. Okay. So 141 is the answer. Correct? Yep. Yeah. Yep. ChatGPT wins again. Let's adjust the scoreboard. Let me have a look at these leaderboards. So how did people do on these? So I did 12. Super easy. I did it in like 15 minutes, so I would probably be in the top 100, to be honest. And I wasn't really doing it at my fastest. I was explaining everything and streaming it, so I think I would have been in the top 100. Okay. Oh, that's both stars. No. I was... Okay, I might not have been in the top 100. It's close. All right. Yeah, both. Probably took me about 20 minutes. Again, I was just out, probably. All right. 13. Hang on. 12. So 634 versus... I'm surprised it took this guy a whole 1 minute 34 to do part 2. You literally change 0 to 1. Well, okay, it does take a bit longer to run, but still only like 30 seconds or something at most. So I'm surprised it took him that long, actually. Oh no, they were different people. 6:46. Okay, it took him even longer. It took... Okay, whatever. Zhao? Oh, okay, Zhao took only 30 seconds. That makes sense. Okay. Alright, what was I actually looking for? Here, this is what I was looking for. 12, 13, 14. Alright, let's move on to 14. It looks like it's the same level of difficulty, so I've got time. We're past the halfway point. Oh, we're in the new building. It's getting lit up. Oh, that's cool. One-time pad. Yeah, I like one-time pad. It's like the unbreakable encryption. Right. In order to communicate securely with Santa while you're on this mission, you've been using one-time pads that you generate using a pre-agreed algorithm. Unfortunately, you've run out of keys in your one-time pad, and so you need to generate some more. Well, if you're generating keys, then it's not really a one-time pad, is it? It's crackable if they know your generation algorithm, so I'd argue that's not actually one-time pad. That's just a standard encryption generation algorithm. One-time pad is going to be like truly random. So you can't have a generation algorithm because that's not truly random, that's completely dependent. Right, anyway. To generate keys, you first get a stream of random data by taking the MD5 of a prearranged salt. Well, how would this work? Does Santa have the same... Whatever. Let's read it. If you're using randomness, then Santa wouldn't have the same keys. Okay. You get a stream of random data by taking the MD5 of prearranged salt, your puzzle input. So our salt is that. Okay. Oh, it's not random. You're taking... That's... It's not random, is it? It's, You're taking MD5 of the salt and an increasing integer index. So it's very pseudo-random, but the generation is known, so yeah. The resulting MD5 hash... So as long as they knew this, if the enemy knows the salt, they can crack everything. Fine. Take the salt, you hash it with the integer to get the next character. Wait, no. You get a hash of lowercase digits, okay. You need 64 new keys for your one-time pad. A hash is a key only if it contains 3 of the same character in a row, like 777. One of the next 1000 hashes in the stream contains that same character 5 times in a row, like 77777. Fine. You have to check the next 1000 hashes. So you have to have a triplet and the quintuplet, whatever, has got to be in one of the next 1000 hashes. For example, if the prearranged sort is ABC, yeah, I get it. All right. We need the index for the 64th key. None of the next 1,000 hashes contain 888. The next index is 39. Okay. Okay. Not hard. No algorithm needed here. Just Wait. So the key is the whole hash itself. Okay, got it. But you gotta search for multiple triples because there could be 2 triples in there together, and you gotta check both of them. So yeah, okay. All right, so the salt is that. So we need, okay. So we need get hash for a given index. So basically, we first have to generate enough hashes so that we can actually do this. So right now, if we called for hash 55 or whatever, we'd have to keep generating hashes until there was enough. So for I in range from length of hashes to Losing my train of thought. Yeah, so from the length of hashes, however many hashes there are, we start from that and keep generating until we've hit x plus 1. So example, if we want 1000, with the index 1000, this is going to start from 0, generate hash 0, hash 1, hash 2, up to index 1000. Yeah. Wait, do we... Increasing integer index starting with 0. Yeah, that works. Okay. So if there's already enough hashes, this for loop won't do anything. All right, so get the hash. So h equals... I can't remember how to do this. Let's see, does it? No. Python MD5 encode. All right, so import hashlib. All right, so we got hashlib.md5. Right, so we use this hashlib.md5. So let me have a look at this again. It's the salt, so it'll be salt plus string of I. That needs to be encoded. Let me check how this... Dot encode, yeah. So that's the hash. Just do hashes dot append that, and then just return hashes index. Let's try that. Print get hash 1000. So we want to get the hex digest of that. So we need to do append that dot hex digest. Try again. There we go. All right, so we've got a way of getting hashes efficiently without. So anytime we call for a hash, whether it be 1 million or something, it will do what's necessary to get that hash, and it will compute each hash only once and store them in a list efficiently. Could also use a dictionary, but list is actually more efficient. All right, next step. So what do we want? We want to start with num keys equals 0. That's how many keys we've found so far. We're not storing them because we don't need them. We just need the 64th one. So I equals 0 while true. So oh, I see why this is going to take too long, because oh, okay. We're going to be going through 1,000 over and over again. So we need to recompute the quintuples of lots of hashes. That's what we need. So how do we do this? Like, what kind of numbers are we dealing with here? It was 64, so yeah, for each index, we're going into the thousands. If we were going to check the next 1,000, that's like 1,000,000 each time. That's like 1,000,000 altogether. Oh, that's actually not too bad. We can deal with the millions. So we could just run it the slow way, but let me have a think here. What we really need is a binary search. Okay, let's start by just pre-computing the quintuples that we have. So quintuples equals dictionary. Every time we compute a new hash, this is the line which does it. That's the first time that hash was ever computed. So we can say yeah, this is, I think what you really want here is a binary search, a sorted list that you can use binary search on to find where the... Alright, we'll just do it the semi-slow way. Okay, so we say, now we check for quintuples in this list. So, quintuples for I or just make it a list. Quintuples because it's going to be in the same. Put an empty set. Now we, for k in range length of, hang on, so h equals that, put h in there. Alright, so for k in length, h, sorry, -5, right? What am I trying to do here? I'm so confused. Alright, well, what do I want the last value of k to be? I want the last value of k to be... so the index would be length of h minus 1, 2, 3, 4, 5. So if it's length... So you have to add 1? Yeah, -4. Yeah, okay, that makes sense. Alright, so, if length of, so we take the set of h sliced from k to k plus 5. If there's only one character, so that means it's a tuple, then quintuples, the last entry, dot add that character, hk. So now quintuples just has a set of all characters which are quintupled in that hash. So now, okay. So we're going through each index one by one. We look at, so h equals hashes, this equals get hash, get the ith index hash. We now have to check all triplets in that hash. So it'll be k in range if length set k plus 3 is 1, that means that's a triplet. Is, well, now we have to do the inefficient thing, which is to check the next 1000 hashes. Which we can do something smart with, for smart to fix later, but we might get away with it. So it might actually run fast. All right, so for j in range, so the next 1000, so we go from next 1000, so starting from I plus 1, finishing on I plus 1000, so we want 1001. if HK, so our triplets character is in tuples, should be tuplets, or I don't know, J, so that would be a set of characters, yeah. Then we break out of this for loop, is that correct? So we don't want to see that. Oh no, one of them has to... Okay, we do want to see one of these. So if that, okay, so if we found that, that means this is a key. So we do num keys plus equal 1. And at this point, if num keys is 64, print just print the value I. That's the index. While num keys is less than 64. So as soon as we've hit 64, we're done. Alright, so I. Okay, and now break out of this for loop. So otherwise we don't do anything and we move on to the next index. Oh, so this might be too slow. It's going to be in the millions, but millions is okay as long as we don't get into the billions. I mean, the example they gave us is going to be the same complexity because they just had a different salt. So they had 22,000 multiplied by 1,000 each time, so 22 million. Yeah, we can do this. Is that it? Run. Quintuples if. Oh, damn it. We need... Okay, we could just get... So we need to make sure that get hash I plus 1,000. Just make sure these are all generated by just calling that. Ha! That was quick. 12,000? That's roughly the same order of magnitude, so that sounds promising. Alright, I was gonna code some binary search to you know, have a binary search table for each character so that we could search to check range intervals. This is complex stuff. I could see how to improve the efficiency of this, but whatever. To make it linear rather than quadratic. Well, it's not quadratic, but it's quadratic in the if you're treating the 1,000 as a variable. Okay, so let's try this. No, it's too low. You're stuck. Blah, blah, blah. Okay. Well, I mean, I think we've got the program mostly correct. Now we just got to fix the bug. All right, let's test it on the seed they had. So the prearranged sort is ABC. I mean, it looks Like we might just be one off or something. All right. It's too low. So we finished early, so we're probably counting some keys that we shouldn't be. All right, let's try this. So ABC. 20371. It's too low. 20371. So out of interest, let's try 65. $25.04. No, it's not that. Okay. I thought maybe I was off by one. Alright, fine. So we're too small. That means we've been finding quintuples that we shouldn't have. All right. Print. All right, instead of 64, let's just print num keys and the index that got that, because we've got something to work with here. Okay, so that's what we've got. So starting from the beginning, 39. So they said the first index which produces a triple is 18. That doesn't count. Okay. The next which produces a triple is 39. We got 39. Okay. Correct. None of the next 6 triples are keys, but the one after that at index 92 is. Yeah, we got 92. Eventually 22728. Damn, what is going on here? So if HK in quintuples. So it was starting off correct. So at some point we are counting keys that we shouldn't be. So either we're being too generous in checking for triplets, or being too generous in checking for quintuples. So is the arithmetic here correct? So K to K plus 3. So the last number it will be the length minus 2 minus 3. And then it'll be minus 3 up to the end. That's correct. If the length of the set. So yeah. This is unique character. So we get hash. It would throw an error if it didn't have the hash available. Right. J in range I plus 1 up to and including I plus 1000. Only consider the first such triplet in a hash. Ah, that's why we're being too generous. It says we should only use the first triplet. So no matter what we do here, we should break out of this for loop. Don't check the next triplets. All right, now run it. 22728. Correct. Alright, let's try our salt. So you only check the first triplet. That's going to reduce the complexity a bit more. $15,168. Correct. Oh my god, that's a complex part too. Alright. In order to make this process even more secure, you've also implemented key stretching. Key stretching forces attackers to spend more time generating hashes. Unfortunately, it forces everyone else to spend more time too. To implement key stretching, whenever you generate a hash, before you use it, you first find the MD5 hash of that hash, then the MD hash of that hash, and so on, a total of 2016 additional hashings. That's all we do? Ooh. This is going to multiply our time by 1,000, so could we need the binary searching here? Well, okay. I don't think there's any shortcut to actually computing the hash. I think we do actually have to do it at that 2016 times. That's the whole point of the stretching, to make someone have to do that. Right, so... So, you take the hash, and 2016 times you do a rehash. Okay, fine. Let's just put it in and see what happens. I would think it might time out, but then quite a reasonable number of people solved this problem, so I would assume it's similar complexity to the previous two problems, which were easy enough, so I don't know. Let's just start again. Just do part 2. Part 2. So new hashes, new quintuples, get hash 2. So H is that. Now for in range 2016, H equals so don't need the hang on. You don't need to hex digest here. H. And now H equals H dot hex digest. And now we do that, and now we do all that same. Okay. Everything else is the same, but we use get hash 2. All right, try it. Object supporting the... okay. Maybe Maybe I do need to hex digest. I don't fully understand this MT5 stuff, so do that. H. String must be encoded. Oh yeah, okay. Now it's... Oh, it's steady. Sometimes it gets in a little bit stuck, but I mean, it's continuous, right? It's not going to get harder as you go along. It's always... You're just shifting along by indices, so it's steady. Just a bit random in terms of how long each index takes to calculate. Each key takes to find. 2864. So it's just different. It's neither going to be bigger or smaller, it's just random. Okay, so... Correct. Yeah, I mean, of course it's correct. You just apply that. I mean, if I did this without the quintuples set, it would probably still work. Just take a little bit longer, but not that much longer. Just a constant factor, because the quintuple stops you having to search through the string every time. But yeah, if you really wanted to make this efficient, you would need like a binary, an ordered list to be able to make range queries, work out if there is any letter B in range, you know, 1000 to 2000, for example. So you'd have a range table for each character. It's not too difficult to do, it's just you wouldn't expect people in this competition normally to go that far. But anyway, it runs pretty quickly, so you don't need to do that. Alright, let's see how ChatGPT handles this. It'll probably manage fine, to be honest. It's just doing MD5 hashing. Given the action produce. Okay, so new chat. Okay, can you write? God, it's so fast. It worries me though, because probably people have been using it before. It might have trained it, so it's hard to test whether it's really solving it from scratch or just using a solution that's solved before. There's no way to really deal with it unless you give it completely original problems. Which I could probably do in December when the actual 2023 gets released. Look, he's got the wrong index though. Oh, because I know why he's getting the wrong index. Because he's using someone else's seed, because someone else has used ChatGPT for this problem. But they added different outputs, so he's just using that, and that's annoying. Alright. Let's test this. Alright, I'm gonna finish the stream after this one. So he's doing it a slightly slower way than me. Because he's not storing the quintuplets, so he's recomputing the quintuplet checks every time. That's not too big a deal, though. But it is very noticeably slower, so that is a big deal, actually. If you're being competitive about this. Hang on. Why has he done triplet times 5? Triplet is a 3-character string. Look, he's taken... So that is 3 characters long. And he's done that multiplied by 5. So that's 15 characters long. He's got a bug. Okay, let's stop this. Alright, so let's see what happens if we fix his bug, but I'm not gonna tell him what his bug was. So what would it be? It would be triplet 0. Just take the 1 character. Now do it. Pretty sure he's done it wrong, because why would you multiply triplet times 5? It's still taking a long time. Let's print the keys. It's not even finding the first key. The code looks right though, but... Yeah, that's correct. I plus 1, I plus 2... hashes.get... Wait, hashes... How? How does this work? How does he know what the future hashes? Oh, I see. No, but the only time he computes the hash is here. But he doesn't compute the next hashes. He computes this one, but he doesn't compute the future one. But wouldn't this error out? Isn't it trying to... Does he call this recursively? No. How is this still running? Why is it not crashing? So he's calling hashes.get j... Oh, he's got a default here. Why has he got a default? So stop. Take out the default. That's just making it run forever. It should now error out, which is more correct, I would say, because now you actually know what's happening. Yeah. He had 2 bugs. He's not computing the future indices and that triplet. Alright, but I'm not going to tell him what the bugs are. He's got to figure that out for himself. So all we can say is it's stuck in a loop. See if he can fix it. Oh, this might look this might be a win for us. Only store the hashes that have a triplet in them. No, that's not the issue. That's not the issue. He's still multiplying by 3. He's still... Oh, now he's actually computing these hash on the spot. Well, that fixes one issue. Let's see what we get. So he's fixed one bug on his own, that's good, but I still think it's wrong. So he's computing the hashes on the spot for the next 1000 hashes. Fine, but he's not really storing those ones, is he? Doesn't matter, whatever. Yeah, but this is still wrong. Look, it should be... It should be like this should be this, shouldn't it? Let's see if that fixes it. $15,168. That's correct, but I fixed it. Without that correction, it's gonna take forever because it's trying to find a 15 length. That's rarely gonna happen. All right, so we're just gonna tell him it's still running forever. Still taking too long. More efficient. Well, triplet. No, he's still doing the triplet thing. He insists on this triplet thing. I mean, I have to be fair. I have to try it, but this is wrong. Sure. No, don't debug. Yeah, it's wrong. Triplet times 5. I don't think he's getting the... Still taking too long. I don't think it is an efficiency issue. There might be a bug somewhere. Give him a clue. That's the best I can do. Triplet times 5, he's doing it again. It's a very strange bug for him to be making because when you see triplet times 5, that immediately looks wrong. Why would you multiply a triplet times 5? The way he's named his variables makes it clear that there's a mistake there. That's why I spotted it so easily. But he keeps trying to make it efficient. Alright. I mean, when am I going to call it? I solved this problem quite quickly. So maybe we'll give him one more chance. He's not making any progress here, so I don't see it. I don't see him actually solving this one. I'll give him one more chance, but I won't give him a clue. I'll just say... There's no clue I could give. Really, I just gotta say, still taking too long. There must be a bug in the code. He's still done triplet times 5, even though he's done a completely different implementation. Nope, he failed. See, if I were doing this in a live competition, I wouldn't even really know that there's a bug. I would think it's an... My first guess would be that it's just it just takes a long time to compute, so I wouldn't be telling him there's a bug. I was kind of helping him out there. One more time. But no, triplet times 5. Alright, let's just tell him what he did wrong. But this is a fail for ChatGPT. There is a bug. You concatenated triplet 3 times, but this gives a string of 15 characters instead of 5. Let's see if he actually fixes it now, but this doesn't count. Right, what? I don't even understand how this quintuplet check even works at this point. Hello, Ku. Yep, I've been making my way through 2016. It's very cryptography based. Like, most of the problems in this are some sort of cryptographic algorithm. This one is MD5. I guess it was just that year Eric really liked cryptography. Alright, I've actually beaten ChatGPT on this one problem because he couldn't find the bug. Alright, I don't understand how his code even works now, but we can test this. Yeah, I literally just paste the whole problem in and say, write a Python program that solves this, and then I just run that program as is. I don't even have to modify it, and most of the time he beats me at it. He just instantly solves it. This is a rare occasion where he's actually failed, so it's going to be 3 to me. I'm just trying to understand this new... I've told him the bug now, because I found the bug. Now, I'm expecting to see a number 5 here, but I don't see one, so how is he checking for quintuplets? I don't understand. I'll just try it. Yeah, but I've basically proved that the competition scene is dead for this, because everyone can just run ChatGPT and solve it in seconds. And that's actually what happened last year. Lots of people did that, and they got to the top of the leaderboard that way. So, obviously, it's still a fun competition, but the leaderboard is it's very easy to break into the leaderboard now. So next year is going to be an interesting situation, because ChatGPT will only be stronger by that point. And I'm using the free version. You can get the premium version, which is much, much more optimized for code. There's like 4 different models you can buy. One of them is specialized for code, and this is not that model, so I could try that, yeah. I mean, I wouldn't use that for my entry, but I could, after the competition ends, I could like run ChatGPT and see if it makes a good bot on a new account. That would be interesting. But yeah, I could try early, but I don't want to. Because it might do something amazing. Even if it just gets me to bronze, I don't know. I think people in the competition wouldn't be happy about ChatGPT being in the leaderboard, even if he only gets to bronze or like 1 or 2 leagues above would too. Because people were not happy about people using ChatGPT for this competition last December. Yeah, I won't be the only one who tries it, but I will be somebody who's streaming it. That's the problem. People will see that I'm doing it. Alright, let me... Oh my god, he got minus 561. What the heck? Yeah, he's failed. How is that even possible? The keys are incrementing. Index is incrementing. How can you possibly get minus 561? The only return values you get are -1 or this one. Keys minus. Nah, he's failed this one. Right. We beat ChatGPT. So that's... three to me. 11 to ChatGPT. But yeah, it's like ChatGPT is able to tackle some quite challenging algorithmic problems as well, like ones involving writing like A-star searches and dynamic programming, which came up in some other problems, which is definitely a problem for the competitive coding scene because, okay, Google Code Jam have stopped their competition now. Like the very last Google Code Jam was last month. I didn't even enter it because I didn't realize it was happening. But they've finished it. Now, I don't know the reason why they've ended it since 2010? It's been going for like a decade. Maybe part of the reason is because anyone could just solve the problems now with, at least in round 1. Probably after round 1 it gets too hard for ChatGPT. Or maybe it doesn't, I don't know. But, I mean... there will be a problem with people just solving the problems with ChatGPT, or even Google's AI, because Google are making an AI as well, so... yeah. So, Google Code Jam is dead. What else? What other... I think competitive coding competitions are slowly dying anyway, even before ChatGPT came around. Like, HackerRank have stopped their competitions. They used to have, in my opinion, the best competitions. Maybe things like Top Coder and stuff are still going, but I've never gone back to Top Coder. But yeah, I think AI will kill the competitive coding scene, which is sad, but I think, yeah, I mean, yeah, I'm actually bored of competitive coding anyway. It was something I was into back when I was just learning algorithms, but it's very textbooky. I do much prefer coding game because it's the problem's more original and it's a bit more improvisational than knowing lots of textbook data structures. So I'm not going to be too upset if the competitive coding scene dies, but I know a lot of people will be because some people were really into it. Did Google even announce why they're ending the code jam? Or is it just the Google way? They just kill products that people like using. That's just what they do. All right, someone has actually asked some engineers at Google about this, but Google has laid off the staff who make these competitions. Oh, well, that could well be the main reason then. Because they did actually lay off a lot of people, didn't they? And so did all the other tech giants. Well, if that's the reason, that's a shame, because it was the best competition of that nature. I mean, coding game is a very different thing, but the problems Google came up with usually didn't need you to know lots of technical textbook algorithms. A lot of it were very original problems. That's what made it great. And I thought they were using CodeJam as well to find, people to recruit into Google. I mean, that's how I got an interview at Google. They found me in the CodeJam. I guess they finally realized that performance in the CodeJam doesn't actually correlate with performance on the job, because I'm pretty sure it doesn't. It's so different to what you actually do on the job in a software engineering company that yeah, but that was back in like 2012, I think. That was my peak. That was when I was best at that sort of stuff. And I did fail the interview, or at least, I don't know, maybe I passed 3 out of 5 or something like that, and I needed 4 out of 5. But yeah, I mean, I never applied to Google. They headhunted me from my result in the CodeJam, which was, I got to round 2, I guess. Or did I get to round? Well, how many rounds are there? No, I got to round 3, and then I didn't get any points at round 3 because it was beyond my comprehension. But I can't remember now, but yeah, that was ever since 2012. I've been entering it every year, and I always get worse and worse. So, but it's a shame because it was a source of great problems, and it's hard to find good problems these days. Original problems. Let's have a look then. So yeah, we're getting there. So how many people solved this hash one? I mean, it's not actually that hard. You didn't have to do anything smart with this, so I expect roughly the same difficulty as the BFS problems. Let's have a look. 15. No. 14. Top guys solved it in like 12 minutes. Pretty sure I solved it faster than 42 minutes. I don't think that many people were on the site in those days anyway. Because I know, I recognize a lot of these people as the same. Alright, so, I think I'm done. That's 3 problems done. So we got to 15 next time. That's nice. They got the monorail. Monorail, monorail, monorail. All right. All right. I owe it to ChatGPT just to tell him. That it failed. Maybe he could learn from that, improve his model. There's a problem though, because people have been using ChatGPT before me on these same problems. So sometimes he's actually recalling stuff he knew from before, which is kind of ruining my experiment, but whatever, I can't do anything about that. Because he definitely knew things that I didn't tell him occasionally. He slipped them into his solutions. And I was like, how did you know that? And he just kind of dodged the question. Alright. I'll be back on later with some Subnautica. I'm really enjoying Subnautica. That's a really fun underwater exploration game. I like to personify him a lot, but as opposed to what would I what would I it? It doesn't really sound right calling it because he's actually talking human language. I don't know. I think if someone's actually speaking English, I can't see myself calling them it. Doesn't sound right. Outer Wilds, yeah, I've seen that people who like Subnautica also like Outer Wilds, so I'll keep that in mind. Um, but I have a couple of other sandboxy games to get through as well, like Satisfactory. So it might be a while before I get to Outer Wilds. And the coding game is coming up soon, isn't it? Like next week or something? Alright, well, there'll be plenty of coding streams to come then. 25th. Oh, okay. Still got time. I can probably complete Advent of Code before then. Yeah, I wouldn't want to keep both of those going at the same time. That wouldn't be good. Well, I'm glad they didn't fully replace the spring competition with that thing we had last time, which was the puzzles, which I didn't like because the site broke and it was totally unfair. But whatever. All right. See you next time, Ku.